The reasoning for installing a grounding grid under a concrete slab for a portable spa, even though the spa has no exposed metal, is due to the presence of electrical components in water. Water is an excellent conductor of electricity, and contact with exposed electrical parts can create a hazardous situation. The grounding grid under the concrete slab provides a low resistance path for any electrical current that may escape from the spa's electrical system. This helps prevent the current from flowing through the water or the concrete slab, which could create a shock hazard. The bonding wire should be connected to the grounding conductor bar in the spa's electrical panel. This ensures that all exposed metal parts in the spa's electrical system are connected to the same ground reference point. The bonding wire does not induce a fault current as long as the grounding grid is properly installed and maintained. The grounding grid provides a lower resistance path for any fault current than the main grounding electrode, because the grounding grid is buried directly under the slab, which ensures good contact with the earth. National Electrical Code Section 680.26b requires a grounding grid under a concrete slab for permanent spas, which are defined as spas that are installed or intended to be installed in one location. While portable spas may not strictly fit the definition of a permanent spa, many inspectors interpret this code requirement to apply to all spas, regardless of their portability. Additional considerations include: firstly, the grounding grid should be installed according to the manufacturer's specifications. Secondly, the bonding wire should be made of copper and size according to National Electrical Code Section 680.26 born. And thirdly, the grounding grid and bonding wire should be inspected and tested regularly to ensure proper functionality. The primary purpose of a grounding grid, in this context, is to create an equipotential plane. An equipotential plane minimizes voltage differences within the area, reducing the risk of electric shock. By providing a low impedance path to ground, the grid helps to quickly clear any fault currents, further enhancing safety. The connection of the bonding wire to the grounding conductor bar ensures that all conductive elements within and around the spa are at the same electrical potential. This includes the spa's pump motor, any metal components of the spa's structure, and the grounding grid itself. This equipotential bonding significantly reduces the risk of a person becoming a path for electrical current. The grounding grid is designed to be a more effective ground than the main grounding electrode, because it is in direct contact with the earth beneath the concrete slab. This proximity minimizes impedance and provides a more direct path for fault currents to flow to ground. A properly installed and maintained grounding grid will not induce a fault current. Instead, it provides a safe path for fault currents to return to a source, tripping the overcurrent protection device and energizing the circuit. Regular inspection and testing are essential to ensure the continued effectiveness of the grounding grid and bonding connections. This includes visual inspections for corrosion or damage, as well as electrical testing to verify the integrity of the grounding path. It's also important to follow the manufacturer's specifications for the installation and maintenance of the grounding grid, as these specifications are tailored to the specific design and requirements of the spa. Understanding the code requirements is crucial for ensuring compliance and safety. While portable spas may not be explicitly addressed in the code, the intent of the code is to protect people from electrical hazards, regardless of the type of spa. Therefore, many inspectors apply the grounding grid requirements to portable spas as a precautionary measure. The size of the bonding wire is determined by the size of the conductor supplying the spa. National Electrical Code Section 680.26 bone provides specific guidance on the appropriate size of the bonding wire based on the ampacity of the circuit conductors. Using the correct size bonding wire is essential for ensuring that it can safely carry any fault current that may occur. In addition to the grounding grid and bonding wire, it's important to ensure that the spa is protected by a ground fault circuit interrupter, GFCI. A GFCI is a device that detects even small amounts of leakage current and quickly de-energizes the circuit, preventing electric shock. GFCI protection is typically required for all electrical circuits serving spas and hot tubs. The installation of the grounding grid should be performed by a qualified electrician who is familiar with the National Electrical Code and local electrical codes. Proper installation is essential for ensuring the effectiveness of the grounding grid and the safety of the spa. The grounding grid typically consists of a network of bare copper conductors that are buried beneath the concrete slab. The conductors are typically arranged in a grid pattern with spacing between the conductors specified by the manufacturer. The conductors are bonded together at multiple points to create a continuous grounding path. The depth at which the grounding grid is buried is also specified by the manufacturer and is typically determined by the soil conditions and the climate. In some cases, it may be necessary to install the grounding grid deeper to ensure that it is below the frost line. The connection of the bonding wire to the grounding conductor bar should be made using a listed connector. A listed connector is a connector that has been tested and certified by a recognized testing laboratory to meet specific safety standards. Using a listed connector ensures that the connection is reliable and safe. The grounding conductor bar should be securely mounted to the SPA's electrical panel. The grounding conductor bar provides a central point for connecting all of the grounding and bonding conductors in the SPA's electrical system. The main grounding electrode is typically a ground rod or a metal water pipe that is buried in the earth. The main grounding electrode provides a connection to the earth for the entire electrical system. The grounding grid is supplemental to the main grounding electrode and provides a more localized grounding path for the SPA. The impedance of the grounding path is a measure of the opposition to the flow of alternating current. A low impedance grounding path is essential for ensuring that fault currents can quickly and safely return to the source. The grounding grid is designed to provide a low impedance grounding path by providing a large surface area in contact with the earth. The resistance of the grounding path is a measure of the opposition to the flow of direct current. A low resistance grounding path is also important for ensuring that fault currents can quickly and safely return to the source. The grounding grid is designed to provide a low resistance grounding path by using copper conductors and by ensuring that the connections are clean and tight. The National Electrical Code Section 250 provides general requirements for grounding and bonding electrical systems. National Electrical Code Section 680 provides specific requirements for grounding and bonding electrical systems in swimming pools, spas, and hot tubs. It is important to be familiar with both of these code sections to ensure that the electrical system for the spa is properly grounded and bonded. In addition to the grounding grid, bonding wire, and GFCI protection, it is also important to ensure that the spa is properly maintained. This includes regularly checking the water chemistry to ensure that it is not corrosive and regularly inspecting the electrical components for signs of damage. Proper maintenance can help to prevent electrical hazards and extend the life of the spa. The purpose of equipotential bonding is to minimize voltage gradients in the area surrounding the spa. Voltage gradients occur when there is a difference in electrical potential between 2 points. If a person is standing in an area with a voltage gradient, they could be exposed to an electric shock. Equipotential bonding helps to reduce the risk of electric shock by ensuring that all conductive surfaces in the area are at the same electrical potential. The grounding grid is one component of the equipotential bonding system. Other components include the bonding wire that connects the SPA's electrical system to the grounding conductor bar, and any metal components that are within reach of a person in the SPA. All of these components are bonded together to create an equipotential plane. The equipotential plane extends out from the SPA to a distance of at least 3 feet, as required by the National Electrical Code. This ensures that anyone standing within 3 feet of the SPA is protected from electric shock. The grounding grid is typically installed before the concrete slab is poured. This allows the grounding grid to be embedded in the concrete, which provides good contact with the earth. The grounding grid should be installed in accordance with the manufacturer's instructions. The manufacturer's instructions will provide specific guidance on the spacing of the conductors, the depth of the grounding grid, and the type of connectors to use. It is important to follow the manufacturer's instructions carefully to ensure that the grounding grid is properly installed. After the grounding grid is installed, it should be inspected and tested to verify that it is functioning properly. The inspection should include a visual examination of the grounding grid to ensure that the conductors are properly spaced and that the connections are tight. The testing should include a resistance measurement to verify that the grounding grid has a low resistance to ground. If the grounding grid does not meet the manufacturer's specifications, it should be repaired or replaced. A qualified electrician should perform all repairs and replacement. The grounding grid is an important safety feature that helps to protect people from electric shock. By following the manufacturer's instructions and the National Electrical Code, you can ensure that the grounding grid is properly installed and maintained. This will help to keep your spa safe for you and your family. The requirement for a grounding grid is not always explicitly stated for portable spas. The underlying principle of electrical safety remains paramount. Portable spas, like their permanent counterparts, contain electrical components and are used in conjunction with water, creating a potential hazard if a fault occurs. Therefore, many jurisdictions interpret the code to require a grounding grid for portable spas as well, to ensure an additional layer of safety. The interpretation of the code by local inspectors is crucial. They have the authority to enforce the code and to interpret it based on local conditions and best practices. It is always advisable to consult with a local electrical inspector to determine the specific requirements for grounding a portable spa in your area. Their guidance will ensure compliance with local regulations and help to create a safe environment. The location of the bonding wire connection is critical for ensuring the effectiveness of the equipotential bonding system. The bonding wire should be connected to the grounding conductor bar in the spa's electrical panel. This grounding conductor bar serves as the central point for connecting all grounding and bonding conductors within the spa's electrical system. This connection ensures that all conductive elements are at the same electrical potential, minimizing voltage differences and reducing the risk of electric shock. The grounding grid's effectiveness depends on the quality of the connection to the earth. A properly installed grounding grid will have a low resistance to ground, providing a direct path for fault currents to flow back to the source. The resistance of the grounding grid should be measured periodically to ensure that it remains within acceptable limits. A high resistance indicates a problem with the grounding grid, such as corrosion or a loose connection. If the resistance is too high, the grounding grid should be repaired or replaced. The selection of materials for the grounding grid is also important. Copper is the preferred material for grounding conductors due to its high conductivity and resistance to corrosion. The size of the copper conductors should be selected based on the ampacity of the circuit conductors supplying the spa. The connectors used to bond the grounding conductors together should also be made of copper and should be listed for grounding applications. The maintenance of the grounding grid is essential for ensuring its continued effectiveness. The grounding grid should be inspected periodically for signs of corrosion or damage. Any damaged conductors or connectors should be replaced immediately. The grounding grid should also be tested periodically to verify that it has a low resistance to ground. If the resistance is too high, the grounding grid should be repaired or replaced. The consequences of not properly grounding a spa can be severe. If a fault occurs in the spa's electrical system, a person could be exposed to a lethal electric shock. Proper grounding provides a safe path for fault currents to flow back to the source, tripping the overcurrent protection device and de-energizing the circuit. This protects people from electric shock and prevents damage to the spa.